Welcome back. This slide is about something called retrograde motion. You read about this when we studied Venus. Venus rotates opposite every other planet in the solar system, and so we say Venus has retrograde rotation. If you look at this picture, you see the night sky, you see this bright object that is Mars, and then you see a couple of labeled constellations. Capricorn and Sagittarius are constellations of the zodiac. Sagittarius is a centaur or an archer. Capricorn is some manner of goat, but I don't know too much more about it than that. Microscopium is a microscope. What's happening here is that you might be able to see the dates on here. This says April 20th, April 26th, May 1st, May 9th, and so on. So what's happening is that as time progresses, this person has taken pictures of Mars at the same time every night over the course of, it looks like, about 6 months. And so at the end of April, Mars was right here. In May, Mars was moving this way. Right? All of these pictures are taken during the month of May. In June, Mars moved like this. So an interesting thing happens here. Mars is slowing down, stopping, and then in the month of July, Mars started to go backwards. In other words, in the month of April, Mars was very slowly moving from east to west across the sky. In the month of June, Mars sort of turned around. Instead of going east to west, it started going backwards, west to east. Over the month of July, it continued going west to east. Over the month of August, it was going west to east, but then it stopped, and at the very end of the month, turned around. And then in September and October, it continued to go east to west again. This kind of motion, where a planet is going in one direction, stops, moves backwards for a couple of months, stops, and then continues going the original direction, is called retrograde motion. Now look, the thing to understand here is that this type of motion happens for any superior planet. This retrograde motion happens for any superior planet. It's, how can I say this? It's not that the planet is stopping in its orbit around the sun, going backwards, stopping, and then going the same direction again. That's not at all what's happening. This is sort of a characteristic because you're standing on the Earth, right? If you were standing on Jupiter, you would not see this path. If you were standing on Venus, you would see retrograde motion, but even more of it, right? And so this odd path across the sky is a function of where you happen to be observing from. So what do you take away from this? Well, the first thing you take away is that for any observer standing on the Earth, every single superior planet exhibits this retrograde motion, right? We do not see this. We never observe this kind of motion for inferior planets. Observing this motion hundreds of years ago is what led people to believe that the Earth and Mars must be going around the sun. This kind of motion is pretty near impossible to describe or to explain if the Earth is at the center of the solar system. And we'll talk about that a little bit more on a later slide. So what do you have to take away from this? First of all, you need to understand what retrograde motion is. You should be able to describe it or even draw it. Second of all, you should understand that we observe this retrograde motion for all the superior planets, for none of the inferior planets.